Good morning and hello everyone.
Morning.
And welcome to the roundtable organized by KDP from Seoul, Korea, and FAD, Fostering Art and Design from Barcelona, Spain, through his material center, Materfad. First of all, I would like to inform you that the session is recorded with the agreement of the organizers, speakers, and moderator. Throughout the entire session, please keep closed your microphones and turn off your video camera. Thank you very much. I am Valérie Bergeron, Director of Materfad and Deputy Director of FAD. If we are together today is due to an agreement between KDP and FAD to bring to Korea the Neomateria exhibition as part of the Green New Deal policy that promotes the eco-friendly transformation of industrial systems. FAD, Fostering Art and Design, based in Barcelona, is a non-profit association of professionals and businesses connected to design since 1903 that believes that design can improve the lives of people. KDP, Korea Institute of Design Promotion, is the only design body in Korea to plan and implement national design policies and strategies. Neomateria, New Materials for Design and Craft, is a material exhibition co-curated with Ivan Rodriguez, new materials expert, for the Consortium of Commerce, Crafts and Fashion of Catalonia. Since the dawn of time, design and craftsmanship have accompanied humanity, supporting and reflecting the evolution of societies. However, the changes that have taken place in recent decades have been faster and more profound than at any time in history. There is no doubt a new geological era marked by substantial impact of humans on their environment oblige us to a maximum creativity for strategic application of materials. In this context, the link between design and society is undergoing a new transformation, a revolution in which matter is reformulated and opens the door to a new way of creating. This exhibition seeks to give a voice to some of the materials called by us Neomateria that represent this change and seeks to highlight the vital role of the designer maker as creator and transformer of Neomateria. Today, the first of 3 roundtables that will take place before the end of the year proposes an open conversation between designers from Korea and Spain. So it's a pleasure to welcome them and to introduce Robert Thompson, Scientific Director of Materfad, who will conduct the session as the moderator of the roundtable. I hope you will enjoy the session. Thank you on behalf of KDP and of FAD.
Thank you very much, Valerie, for the wonderful introduction. I want to welcome you all to the session. I hope this session will provide you with some interesting ideas regarding new materials, new applications, new designs, and new futures. So here with us today, we have 2 designers, well-renowned in specific areas of design and thought. On the one hand, we have Silvana Katazin. She is a European designer. She's the co-founder and creative director of Naifactory Lab. This is a company that is based in Europe. One of the aspects of their creations and of her creations are the use of resins with waste products, more specifically the use of olive pits, which are the seeds of the olive, which is a very hard material. And these have found their way into interesting new applications. On the other hand, we also have Kim Hyun-ju. She is a Korean-based designer. She's a product designer. She received in 2008 a Red Dot Award, prestigious award for concept thinking and design. In 2009, she started her design studio located in Seoul, launching in 2015 Plus Nature, which is a product concept, accessories for the home, for instance, that are based on biological and biophilia. So today here we'll give you a brief introduction on resins and their properties, and then we will proceed on interviewing our designers regarding their projects and regarding the processes that they've used to come up with new designs and applications. So what is a resin? A resin is a very old and very specific type of material class. Often when we talk about resins, we are talking about one component of another more complex and composite type of material. And I say composite because usually resins form part of a composite. This implies that resins are a type of material which functions as an agglutination component. This means that it can take other elements which can be very diverse. In fact, it could be particles, these could be fibers, these could be aggregates made from minerals, made from natural materials or synthetic materials. And resins have this wonderful ability to bring these aggregates together and hold them into place. And so as a result of this process, we get a composite material which has properties of both, but the properties of both is actually elevated to more than the sum of those properties. So we have sort of a synergy. And essentially, to understand this in a better envelope of cognitive association, we can say that resins are a binding agent. This is a typical word used in material science. And of course, there are many different types of binding agents. So on the one side, we have, for example, synthetic types of polymers. These range in different types. For example, more common versions are the polyesters. There's polyester resins, which is a synthetic polymer. We also have epoxy-based resins. These tend to be a little stronger than polyester and a little more dense. But there are other types of resins as well. We're talking initially about rigid types of resin. But there are also more flexible types of resin. And these are the polymer or the rubber polymer resins. Typicals are the polyurethanes, and also natural rubbers like latex or caoutchouc, which comes from the natural caoutchouc tree. But today we'll be centering more on a later trend of these materials, a trend which is based on the idea that resins typically are very difficult to recycle, and they often do not biodegrade. And so the recent movement in development of resins has been more centered towards the development and applications and innovations of biologically based or biopolymers or bioresins. And these can be very, very diverse as well. For instance, sugar can constitute a bioresin because sugar is a crystal and we can melt that crystal and we can solidify that crystal into a resin. But there are other more sophisticated versions of these bioresins that we are applying today. For example, corn-based bioresins, also that come from the protein known as zein. This is often cultivated in agriculture, especially corn or wheat or barley. There are also other types of more sophisticated resins that are being developed today through the use of the integration of different types of scientific techniques, especially chemistry and thermochemistry and biochemistry. And these constitute resins which are based on proteins. So today we find that on the market there are also protein-based bioresins, and there are also collagen-based bioresins. So this is a brief introduction about resins and their functions within the material, say, realm. But the focus is not on this today. The focus is on examining the very diverse and interesting ideas that inventors and designers are currently using resins today. And so I would like to now migrate perhaps more into the interview section. And I would like to perhaps start with you, Silvana. I'm astonished at the level of complexity and the level of detail which you were able to achieve in some of your products. I'm wondering if you could briefly tell us a little bit about yourself, perhaps a little bit about the materials that you're coadjuvating into these new shapes and new functions, and perhaps talk a little bit also about your process.
Okay, thank you very much. I'm very proud to be here. And I'm Silvana Catazzini. I'm a multidisciplinary designer. I work with, I do objects, I do art installations, ephemeral architecture. And I started to work with biomaterials to apply my work, you know. And Re Olivar born when I was during a summer course in Barcelona, called sustainable materials to applying design, no? And I was lunch nearby the school, and I need to find ways to start to work. And when I look at my, when I was lunch, you know, when I look at my dish, when I finish, I look at my dish, and I saw the olive pits look at me, no? And I thought, maybe I can do something this. And I taught them, I showed to my teacher. My teacher was Robert, no? And I asked her, hey, Robert, what do you think I can do something with this, no? And he say, yes, of course, let's try, you know? This is the short story. I invited my partner to continue the research with me, you know? And
yeah, so I was doing some other jobs, different things, and then she came with this idea, crazy idea. At the beginning, it was like, wow, I've never worked with anything like this. No, I'm architect but I used to work with materials developed by someone else. So it was the first chance for me to start to do our own material. But then I saw what she got to during this course, and I was really surprised. So we started to, okay, I decided to enter in the project, and then we started to research a little bit more about this waste. So we got to this incredible information about olive pips, because they are, well, Spain is the main producer of olive oil. So we have a lot of waste in pips. And then we started to ask to the olive oil industry, and they said that they have no use for these bones, for these pips. Most of the times they burn it, or sometimes they sell it also to cosmetics as an additive. But it's a little tiny part of the 27,000 tons of olive pips that we produce each year. So we had a lot of waste to work with. Then
that's fascinating. That's fascinating aspect. Yes, sure.
And in fact, what we got, this first material that was worked with those olive bones that she found in her dish, then we needed more quantity, you know, and also processed olive bones, because to work with, you need to break it and to get this different textures. And it's not easy to break it, it's quite hard. So we found an industry that they take the olive bones from the olive industry, and they micronized, I don't know if you say it like this, so we can get almost dust from these olive bones. And so we had this new material with us, and we started to experiment with it with different kind of resins. And we got to different formulas and different materials, really interesting because they were quite hard and quite beautiful. And so we started parallelly to this creation of the material, we started to apply it in different products because as designers and artisans that we are, we can't help to do things with the materials that we get that in our hands. So now we had our own material and we started to do things with it, you know, create pieces, and just like artisans do, like we did before with ceramics and vegetable fibers and so on. And well, these first pieces that we create, we started to show them in some events and fairs. And we saw that there was a quite big interest in public about this new line of our work. So we decided to focus on this 100%. And this is when we enter in a project here in Barcelona in the Fab Lab, and they helped us a lot with mentoring and the possibility to use some other technologies like CNC cutting or laser cutting or 3D printing and so on. So we started to create pieces with another with a wide range of possibilities. We could cut and we could also get some information about other additives that we could add to the formula in order to get different kinds of properties to the material. And this is more or less the period when we started to experiment also with natural pigments like turmeric or woodlouse, and it was really nice to see also that we could change the color just with things that we could find in our normal stores, or even here in the mountains where we got some natural pigments, local natural pigments. And well, some of the images that you see were created during this period. No, for example, this image is the inspiration was this leaf that you got on the left part of the image, gave us the idea of creating this other this element with our material.
This we make to the children is a toy. Because I think it's very important to start to see the world with another eyes, no? To see the possibility of the waste to converting materials to work. So, but we need to be a lot of designers doing this. No?
Absolutely. Yeah. I think it's always a wonderful thing, first of all, to see kind of how the initial steps of a project are actually born, you know, from an observation, and to watch them grow and to become actual reality. It truly is a beautiful material, and you know, it has this very warm tone to it. It's a very calming effect. You know, I see potential applications. Now, maybe you can perhaps give us some ideas on these applications, but the initial applications, Josean, that I first imagined is, of course, you're an architect. So materials of this type, I'm wondering if they have, you know, some kind of extra property, like maybe thermal or structural or perhaps textural, or maybe even the ability to welcome other life forms. I'm wondering if you could go into some of your ideas of how this material could be applied in what sectors and why.
Yeah, well, since we started to communicate the results, we got a lot of feedback from different sectors, no? Like from furniture to cosmetics or to olive oil and so on. So we are like trying to focus ourselves in one thing to start to build our business about this material. But as long as we see it, it is possible to be applied in quite a lot of things like from furniture. In fact, that's one of the things that we're starting with, because there's an enterprise here in Barcelona very interested in developing a new line of furniture with this material. So we started the project together. But also, we see that if we can create like big panels of this material, we can use it for construction, for example, or ephemeral architecture. That was one of the things that we started, that we wanted to work with, because it was our main job. We started in design with architecture for stands and fairs and events, so on. And we saw a lot of things that were thrown off after the event. So we saw every work we did, we saw how many things were thrown to the trash. So we wanted to create something that we could work with, and if we throw it to the trash, it is biodegradable. So it's no problem for the planet. So this is one of the things that we would like to work with also.
That's great. That's fantastic. I'm wondering if you could, or if this is something you can talk about, wondering if you've experimented with different types of binding resins, as I take it, perhaps, if you could tell us a little bit about that.
Mm-hmm. Well, some of the binders that we've used, that we create formulas, were pine resin, which is interesting because in Spain we got plenty of pines, so we can work with this resin, local resin in some terms. Also, we used a collagen resin, and we also use agar. So we tried with these three kinds of resins. We also tried with cornstarch and with tapioca starch.
But does it work? And also with alginate
mm-hmm.
also. But for us, these three.
See, these first three are the best for. I mean, the best materials we got to were with these three. Also, we have to add some other additives to get to the final formula, but those three work quite good with olive pips. And there's one thing interesting that I wanted to also to talk about this material, is the fact that we can melt it if we don't like it, or we get, for example, if we do a toy for children, and that children grow, and there's a point where they don't want to play anymore with this toy. So most of the toys were done with plastic, so these toys become garbage just in a second, no? But if it's done with this material, we can also throw it to the nature because it's biodegradable, but we also can melt it and put it in a new mold and create another toy for these children or another object. So it's not only biodegradable, but it's reusable. So we can give this object few other lives after this original use.
Can I ask a question?
Uh-oh.
Please.
It seems that we lost the connection with Robert, maybe, or we don't see him. But please, Yonju, ask your question and present your project. Thank you.
First, Silvana and Jose, and it's a beautiful project, and I love the material you created. But I wonder how strong they are. Has a water resistant or the heat temperature, and is it easy to break, or just I wonder?
Yeah, well, in terms of resistance, mechanical resistance, it is quite strong. Really, it's really strong. I mean, also for impact and for flexion and compression, it works very nice. It's not
the wood, the more
the brown material, the one, not the transparent is is not that thick, so it's more like a bioplastic. But the brown one is really strong, and that's the one that we are using for furniture and also for making panels. But in contact with water, it is quite resistant, but it is not resistant for long use in contact with water. I mean, if it gets wet with the rain, for example, it won't melt down. But if you put it under the if you put it in the water for a long time, it will decompose little by little. So that's what it makes biodegradable in a fast period, like in 3 weeks or 4 weeks. In contact with water, it will disappear.
But we still research, you know, to find to put the others
additives or coatings. I mean, depending on the use that we want to do with it, or the client, for example, if there's an enterprise that wants to use this in contact with water, we are planning to use some kind of natural coatings also to protect the material.
I really love the designs, the kind of nature-based, especially in this image that we're seeing here. That really kind of brings me to some other aspect that I would like to perhaps invite Kim to share some of her inputs on her projects and her designs. I was looking at your website yesterday, and I was appreciating all the shapes and the nature, the biophilia, nature-based designs and shapes. I'm wondering if you could elaborate a little bit on your use of this shellac resin, which is actually quite a traditional kind of resin, which is historically used in the furniture industry. But I'm interested to see what you have to say, Kim.
Okay. Hey, hi, I'm Hyunju, and industry designer based in Korea. So, well, my project, which on this video, is a flexible hanji tray made of a Korean traditional paper. Hanji means Korean traditional paper in Korean, and then finished with a shellac, so which makes it water resistant and reusable. So my project, I always got inspiration from the nature. I don't know why, but since I was little, when I feel upset or blue, I get happier when I see mountain and beautiful blue sky. I think that we are part of nature, you know, human also part of Mother Nature. So it's very natural to feeling that way. And also, when I finished my study in the university, I wanted to start my studio and make my own product. First project I made with resin, but not natural one, chemical resin. And it was just a prototype, and I was thinking to produce that furniture, but the cost was a lot. So, you know, just a startup company cannot afford the amount of cost. So, you know, there are so many designer maker who is making their own product after studying product design. In the case, we cannot just jump into their industry with plastic or other materials. We are not appreciative about that, but also it costs a lot. So we can see lots of designers are working with ceramic or maybe stones or paper, metal, or other natural materials. That is one point that I've been working with the natural material. Another reason is I just love nature and the shapes and the feelings. So when I started with the hanji, the Korean paper, I wanted to try something that is not used to made with the material, because it's a paper, so there are many lightings, and it has been used for flooring material or stationery, maybe decorative object. But plate is plate or tray totally different approach because it's paper, it's not water resistant. Of course, we can use a plastic coating on the surface, which makes them waterproof, but I didn't want to use that plastic material. So first I started with ochil. It's similar with shellac, but it's different. The Korean traditional shellac is more European style. Actually, I didn't know when I started to make my product 2013. And I think you can see those brown papers behind of me. They are lacquered with ochil, Korean traditional natural lacquer material. And the problem is the more I use them, the more darker. So I wanted to make a greenery or maybe a lead bright color of my leaf trays, but I couldn't do that. But suddenly I got a phone call. Actually, I was on the Korean television about introducing my product, and the guy who's supplying shellac, he called me the following day and he introduced about the material. So since then, I love material, but I'm not very good at it. I don't have much information. So he sent me a samples and gave me or certification or characteristic. So I thought it's really nice material. It's the material from insect in India, that area, and it's been used for a long time for coating violin, but also it's using for food ingredient, so such as xylitol gum or aspirin. If you look at the tablet, you can see they are shiny because it was coated with shellac. So actually, we can eat that material. But we shouldn't, because if you drink that, it's getting harder and it will block your throat. So not a good way. So never try that way. But if I didn't make a trays for food, I could have other options. But I wanted to use food safety materials. So I studied about the material and started. And the problem is the shellac is vulnerable with heat and alcohol. So actually, if you pour alcohol on the surface, it will be melted. So which makes it easy, short biodegradable time, but not very strong. So I asked you to Silvana and Jose earlier how strong their product, because I have similar problem. So when this shellac coated material, we can wash them, but we cannot use a dishwasher. No, we cannot put them in the water for a long time. Otherwise, it will be wet eventually. But it's a biomaterial. I think there are pros and cons. So the other characteristic of my paper tray, they are flat actually in the packaging. They are flat like this, but has an aluminum structure inside, so we can make it a shape. So this is a shaped one, and they are flexible, so flat and flat, but you can make a three-dimensional object. By working with the traditional material, I wanted to give some fun to people who use it, because when we're thinking about traditional, what is thinking about antique or just keeping that style, master craftsmanship. But for me, the tradition is alive and it has to be continued. Otherwise, it will disappear, and the future, like 100 years later, people will not remember about that material and tradition. So that's what 100 trays are.
That's very true. I find it interesting, the idea of the productization, like how you've worked in the idea of having, a metal structure on the inside so that you have multiple positions and perhaps even packaging issues of this type. You know, whenever we use biological materials, we have to work within specific limits, because what makes biomaterials so amazing is the fact that they do biodegrade and they are subject to water sometimes, or alcohol or heat. But I find it interesting, though, that a lot of these problems can also constitute opportunities. And I'm wondering, perhaps, you know, I'm asking Silvana, maybe some way that you guys could integrate your materials, you know, like perhaps olive particles could increase the heat resistance of the resins, or perhaps even the use of shellac as a binding agent could be used with olives as a glue of some kind. I'm wondering if you have any one of you has any ideas in that regard.
Mhm. Yeah, I was wondering when I heard you explaining your project, which I find amazing.
Yes,
Congratulations. Especially when you talk about your connection with nature, is something that we also feel. And I guess that's what brings us to this to work within this universe, you know, of biomaterials and nature inspiration.
You respect the nature, you know.
Mhm.
Yeah, exactly.
Yeah. And I was asking myself, what with this paper, you use the shellac as a coating for the paper, or you introduce the shellac in the paper formula?
Finishing material. I use shellac for finishing material. It's just a pure hanji, but there are two layers because I put aluminum vein structure inside. So when I glued them, I did use potato glue. It's like a potato starch. Yeah, glue them. And then just applying shellac with it's very easy, because shellac is some people find it difficult because it's very hard material. But I can buy shellac, which is made in liquid. When you use shellac, you have to mix with alcohol and then applying on the material. But I can get the material easily from my supplier. So for me, it was easy. But I found some people, it's difficult for them.
Well, certainly there are some aspects that, you know, both of you could consider, which is there are some other natural materials that are available that are actually not that costly, that can alter some of the thermal properties of resins in general. So, you know, these are normally they're considered clays. So when you apply like these particles of clay, the clay has this really good way of absorbing excess heat, and that takes away the heat from the material that's binding the clay. So that could be one aspect that both of you examine, especially in architectural applications, and it wouldn't necessarily interfere with the properties. Now, where do you see, I'm very interested and very pleased actually that both of you have such sensitivities towards, you know, the need to have a better future in terms of our choices of materials and what we do and how we conceive products. I'm wondering if any one of you has any ideas about what you think the future it will look like or what it should look like.
This is tough one. Well, I think we will go for more biodegradable material. I think I went Eindhoven last year, and I think it's October Dutch Design Week, and the theme was sustainability. And I've been working around many places, which showing new materials. It was very, very fascinating. There are so many materials made of vegetables like apples, or made of coffee powder, also made of how can I say more, you know, like mushrooms, and they has beautiful texture and very interesting and biodegradable as well. But the problem that I cannot use the material now. It's still developing and has a certain kinds of a problem that we can use in daily life, like a water resistant problem or durations, the cost as well. But there are so many people, so many good people inventing new materials, and we also aware of all those materials, like a Neomateria exhibition or other exhibition. So maybe 20 years later, we could find new biomaterials, and it can replace the total plastic product, I guess.
Interesting.
What I see for myself is that we have like two lines of work to get to the future that we would like to have, which I don't know what it is, but what I know is that if we work only in biomaterials, developing biomaterials, but we don't work or we don't care about how we use them or how we use the rest of things that we have now, like plastics and metals and so on, probably we will have problems on the future. I mean, we have to change both things, materials and also the use that we do. We have to change how we consume, because plastic, I think that will never disappear. Plastic has to be used the way that it's better for this material and for us. But if that's the problem with plastic, if we don't change the way we use plastic, probably we will never get to a healthy planet, because the time it will take to substitute plastic with other materials, it can take 100 years.
Yes, it's very true.
So that's what I see.
But
I find it interesting. Yeah.
Yeah, sorry, Robert. I think, yeah, that's a very good point. And people are very slow, but they are trying to be changed. For example, since I was working with a paper material, then I got so many questions at the trade fair. They saying, is this biodegradable or disposable paper plate? So it was my product was reusable one. So, and then I thought, wow, so many disposable paper plate has plastic coating on the surface, and it's just a one-time use, and it takes like 100 years to be biodegraded. So the next project I started was a biodegradable paper plate. It's actually a single-use product, but only paper pulp is the material. I didn't put any plastic coating on the surface, but it has high density, so we can use them like a normal paper cup with films on it. And then I got a project with a big hotel chain in here, South Korea, and they asked me whether I can make a biodegradable amenity kit. Actually, there are so many hotels, and they giving small amenity kit in a plastic bottles, and they changing it every day. We don't travel nowadays because of Corona. We don't travel much now, but in the last year, if we thinking about how many amenity kit plastic bottles are consumed in 1 year, that's amazing. So it could be big challenging for the company, has to invest quite a lot of money to develop like an aluminum mold and a big number of production. But they did it, and it was a very good example, I think. And the Korean government also saying they are not allowed the hotels to using plastic bottle to giving amenity kit anymore, maybe in 2 years. So it's a good time changing.
Absolutely. Especially in the world of packaging. It seems that packaging is probably one of the sectors that is most offensive because of the sheer fact that it's destined towards the use of individuals. And And so you need certain specific resistances to foods, but also architecture is a huge field of CO2 production, and the involvement of cements and the use of minerals. And I'm sure you guys are thinking about that when you're thinking about olives as well, right?
Mm-hmm. Yeah, definitely. Yeah, and especially me as an architect, I built a lot of things in the past, and now when I think how much pain I created to the environment, I have a lot of work to do to compensate this pain that I created in the past. So now I'm kind of focused on what can I do as an architect. And for example, like a month ago, there was a client asking me for me to do a house. And first I looked like, no, I don't do houses anymore. But then he said, no, but I want to do a house with earth walls,
Sure.
And I said, oh, that sounds interesting for me. And when you start to research about this technique, you see that it's a very old technique, like hundreds and hundreds of years. And it makes a lot of sense because you work with the material that you have in the place. You take the earth that you're gonna dig to make the foundations, and you use this earth mixed with some other things, and you make the walls of the house. It makes a lot of sense. No? Exactly. So I see that architecture has to look always forward, to new materials and new solutions, but also has to look into the past and see what people did in the past, because people were more sustainable in the past, not because they think that sustainability was nice, because this was the only option.
Right.
So we have to go back a little bit to this mindset.
Well, I definitely see, the use of biomaterials as actually making more options. So today we have this benefit, one of the aspects, Kim, that is very interesting about your projects is the use of cellulose. Cellulose is paper, and it is a wonderful, wonderful material. In fact, cellulose could be used also with the conjunction of olive pits to create kind of a tensile element, because fibers of cellulose tend to be very good in tension but not very good in compression, which is why we can kind of switch it around and twist it. So the interesting fact about talking to designers like yourselves and innovators in the field is the ability to see how new materials can come from mixing those materials that you have been working on individually. And perhaps this is a good way to pave our way towards a future which is more invested on good ideas, right? And as you were saying, like, should we do something? Should we continue to make things in the same way? What do you think about that? Like, do you think the future should be more man-made? Do you think it should be more 3D printing? Both, perhaps? What is your opinions on these aspects?
Me?
Sure.
Well, I think in the last 200 years after Industrial Revolution, so many things changed, like the materials, or the way of living, and also art, craft and design. But now I thought we back into craft era. People are more thinking about craft than like 30 years ago. At the time, high tech and design mass production was very, very popular. But now people wants to have, it's just my point of view, but people wants to have something special, not something is unique, and they are bored with mass production plastic product. So I think it's a cycle. We could going back to past if we're thinking about like 100 of years. Even at the time we didn't have oil, we didn't have gas, and no plastic. But they find a way of living and found the good natural materials for making the object for our lives. So in the future, I think it's difficult to changing and stop to using plastic in short time, but they are aware about that and will be changing, going back to the past, maybe using more natural resources and materials. 3D printing has a different way. It's not very good at it, so.
Sí, but I think that we can change the future. No, my first motivation is preserve the future for my doctor, no, for our doctor, and the maker movement now is growing. So we as designer, we can inspiration other designers to grow this biodegradable movement to make more materials, no? Mm-hmm. So I see the future with more biodegradable, mm-hmm. No?
Then what I see, yeah, definitely, it has to be. But what I see is that also biodegradable materials and non-biodegradable is the use that we do of them. That's what I said before. But what I see is that one thing that's really important in the future society is that we invest more in creativity for everybody, not just for designers, but also for normal people. And I think that crafts is something that can help people, just as gymnastics, as exercise does. No, today everybody does some kind of sport because it's really healthy and it's like politically correct. So everybody has to do something. But I think that creativity and crafts creation should be also a part of what it's what people has in their lives. And today most of people buy creativity done by some other people, creators and artists and so on. But I think that in the future we should encourage people to create their own pieces, but not also as a decoration piece, but also to solve problems. Because you don't have to create a beautiful piece for yourself, but you can also have the satisfaction to create a piece that's solving a problem for you. It doesn't have to be beautiful. It doesn't have to be an incredible material, just the satisfaction of doing yourself your own necessities, no? Like 3D printing, for example, can help a lot in this way. I mean, you can, instead of going to a mall and buy a piece of machine that's broken or something to fix something that's broken in your house, you can make it your own, and you will be more sustainable, and you also will be more satisfied. No, so I guess I imagine a future where people can solve their own problems with their own hands or with their own technology. Like Fab Lab, for example, is a concept that is working in this direction, no? Creating production centers where you can go with your pen drive and you can print something that you are needing. You don't have to buy it and from China or from wherever and ship it to Spain or to somewhere else. You can do it in your place, in your home, in your neighborhood. That's what I see.
Thank you for that, Josiane. I think that's interesting. It's very true what you're saying. The whole idea of creativity is something that actually fascinates me. I'm wondering, Kim, how do you create? How is it that how do you create your structures or do you work linearly? Do you get inspired by nature? What's your creative technique?
You know the answer. Yes, I got inspiration from the nature. Well, I'm not that type of person just to keep focusing to developing my idea on desk, doing a little sketchy. it doesn't bring me good idea. So, you know, I used to travel a lot and I love nature and going outside and finding, discover new things, and it brings me lots of ideas. And then I'm thinking and do some sketch and then use 3D programs to developing, realize my ideas. That's how I get it. Yep.
Okay, so you take inspiration and then you try to use some kind of technology to visualize, perhaps, right? To design the system or what it looks like, maybe the proportions. And I'm wondering if both of you have a materials-based approach towards design, or is it more you apply the material to a design later? So which one do you actually use? Do you get inspired by a material, or is it that you apply material onto an inspiration?
I put material first, then design, and try to find a good way of making and design to showing the character of the material.
Interesting.
I would say
No,
both. No? I would say sometimes it's the material that's giving the shape, the final shape. We don't know what's going to be. So we repeat the same method, and the own material gives the shape, the final shape. So it's kind of it's like when you bake bread or something, you don't know what it's going to be like at the end. No, sometimes it's like this, or it's more brown, it's more dark, it's more. So some of the pieces are like this. Some other are, you know, we make a sketch and then we put it on the computer and then we analyze it and then blah, blah, blah. So, and we go to the final. And that's it's curious because this is the second part of creating is the one that you get more like disappointed with, you know, because you want something and real life doesn't get you what you want, especially with biomaterials, no, which are more like alive, no. And when you leave the material like free to talk and to express himself, you always get like really happy with the result, no. And so it's a combination.
I agree. I mean, it's kind of a learning curve. We come from a society that has always been focused towards a scientific method and trying to increase our precision and our control over materials. But in reality, perhaps a better approach would be to listen, to observe, and to adopt new ways and to allow imperfection. Maybe that will bring us more harmony in the future. And I want to applaud you, for both of you, for your designs and your work and your inspiration. And I want to hope the best for your products and your methods of design. And I want to thank you, of course, very much for participating in this session. It was eye-opening, it was inspiring, and it was a wonderful thing to do. Thank you very, very much. And Valerie, if you would like to perhaps close the session.
No, I'm totally with you. And I have to say that someone asked a question that we will send to Yungjo because we have no more time to left for the session. And I thank you very much, both of you, fantastic speakers. Thank you, Robert. And thank you, our institution, KIDP and FAD, to give us this opportunity. So just remember that we will have 2 others roundtable, and please, we will inform you through our canal of communication of our institution. Thank you a lot, and we finished now the session.
Okay, thank
you.
you.
Thank you very much.
Bye.
It was a pleasure. Congratulations on you.
Sí, sí, sí.
Thank you.
Thank
Thank you both.